Hello everyone, welcome back. Today on Quantum Science Hub, we are diving into IGCSE Chemistry about electrochemistry, walking through carefully selected past paper questions from the last 5 years. So, let's get started. Question 1. In the electrolysis diagram, oxidation is occurring at electrode 1 and reduction at electrode 2. Which row shows the direction of movement of the electrons in the external circuit and of the positive ions in the electrolyte? Okay, I already explained about this topic in my previous video of complete revision about electrochemistry. So if you still confused or you forget, please watch my video again. So the first clue that we should know in here is the oxidation happened at electrode 1. So if you still remember, oxidation happening at anode, right? Anode means it is the positive electrode. So this is the positive electrode. Then electrode 2 must be the opposite, which is the negative electrode. And yeah, it is very clear in here, reduction at electrode 2. Which row shows the movement of the electrons in the external circuit? So what does that mean of the external circuit? It means it is in the cable in here. So if you still remember, how is the movement of electrons in the external circuit or in the cable? It moves from the positive to negative, right? So the arrow must be like this because this is the positive and this is the negative. So it moves from positive to negative. And what about the ions? So as we know, this is the negative electrode. So who will attract it to negative? Something positive, right? So all the positive ions will attract it or will move to this side, okay? Let's check the answer. So the direction of the movement of electrons in the external circuit moves from electrode 1 to electrode 2. Okay, so I'm gonna lock my answer between A or B. And the direction of movement of the positive ions in the electrolyte also move from 1 to 2. From these electrode move to these electrode. Okay, so the correct answer here is A. Next question, which row describe an advantage of using the hydrogen-oxygen fuel cell and an advantage of using the petrol engine? Okay, so option A, can travel a greater distance after the fuel tank has been filled? Yes, that's correct. The advantage for petrol engine here does not produce carbon dioxide gas. As we know, the petrol engine still produces carbon dioxide gas, right? So this is not the advantage because it will cause global warming. Okay, so this is the disadvantage. So this statement is wrong. Next, there are more petrol filling station than hydrogen filling station. No, this is wrong. And no risk of fire or explosion if the fuel tank is damaged for petrol engine. Yes, that's correct. Next, does not produce carbon dioxide gas which causes global warming? Yes, that's correct, because the product is only water, right? Hydrogen-oxygen fuel cell. So the equation is H2 plus O2 will produce water. H2O. So this is a very clean energy, so it will not produce carbon dioxide gas. Can travel a greater distance after the fuel tank has been filled? Yes, of course. Option D. No risk of fire or explosion if the fuel tank is damaged. Okay, so this is wrong because hydrogen-oxygen fuel cell is very sensitive to high pressure and high temperature. So if something bad happened to the fuel tank, it will explode and the explosion is very huge. It can destroy everything around it. So this one is wrong. There are more petrol filling station than hydrogen filling station. Yes, this is correct. So the correct answer here is C. Question 3. Dilute sulfuric acid is electrolyzed using inert electrodes. What are the ionic half equations for the reaction that take place at each electrode? Okay, so what is the formula for dilute sulfuric acid? H2SO4, right? So we split based on the ions, which is H positive and SO4, 2 negative. While from the water itself, H2O is H positive and OH negative. So the clue here is dilute. So what is dilute again? Dilute means it contains a lot of water. So if it's contain a lot of water for negative ions, we always take the OH negative. So who will attract it to positive? The negative ions, right? So we will take the OH negative. So the equation is 4OH negative will produce 2H2O plus O2 plus 4 electron. So this one. While the negative electrode, you don't have any other choice because you can only choose H positive, right? So this one. Then the correct answer here is C. Question 4. Which statements about hydrogen-oxygen fuel cells are correct? Okay, let's take a look in here. Statement 1. They convert chemical energy into electrical energy. Yes, it is. Because hydrogen H2 plus oxygen O2 will produce H2O, right? So they convert chemical energy, which is H2O, into electrical energy. So statement 1 is correct. Statement 2. Hydrogen is reduced in the fuel cell. Okay, because hydrogen gain oxygen. Gain oxygen, that is what we call oxidation. So hydrogen is oxidized in the fuel cell, right? So this is oxidized, not reduced. So this statement is wrong. Next, they do not produce any atmospheric pollutants. So what is atmospheric pollutants? So it is like carbon dioxide, carbon monoxide, or any pollutant gas like oxides of nitrogens, right? Which can cause respiratory problem or global warming. So this is a clean energy because the product is only water. So they do not produce any atmospheric pollutants. Yes, that's correct. So the correct statement here is 1 and 3. So the correct answer here is C. Question 5. The diagram shows the electroplating of a steel object. So this is the electroplating. A student makes 3 statements. Okay, let's check the statement in here. Statement 1. The steel object turns a reddish brown color. Okay, how is the movement of ions in electroplating? Remember, in electroplating, the ions move from positive electrode or anode to negative electrode, right? So the ions, which is Cu2 positive, will move from anode to cathode. So what will happen to the copper electrode or the anode? So these will become thinner while the steel object will become thicker because the ions move from anode to cathode, just like changing place, right? And what is the original color of copper ions? It is reddish brown color. So the steel object, which is this one, turns a reddish brown color. Yes, because it is covered. It is coated by the copper ions, which is reddish brown color. So statement 1 is correct. Statement 2. The aqueous copper 2 sulfate changes to a paler blue color. Okay, so as we know, the copper ions, it is just moving from anode to cathode. So that means the concentration in this electrolyte is still the same. There is no changing, right? So since there is no changing, so that means the color still the same like the original color. So the color will not change to a paler blue color, right? So statement 2 is wrong. Statement 3. The copper electrodes become thinner. Yes, just like I told you before. So the ions move from anode to cathode. So these anode will become thinner and these cathode will become thicker. So statement 3 is correct. So the correct statement here is 1 and 3. Then the correct answer is C. Question 6. Concentrated aqueous sodium chloride is electrolyzed using inert electrodes. Which equation shows the correct ionic half equation for the reaction at the anode? Okay, so the question here is at the anode. Anode is positive electrode, right? Now let's talk about sodium chloride. So sodium chloride, it is an ACl, and from the water, H2O. So let's find out the ion. And ACl, the ion is an A positive and Cl negative, while from the water, it's always H positive and OH negative. Now, please take a look at the question one more time. It is concentrated, right? So that means you have more sodium chloride than the water. So concentrated means it contains less water. So the water here is less and you have more NaCl. So who will attract it to a positive electrode? Negative ions, right? So you can choose between Cl negative or OH negative. But the question here is concentrated. If you still remember the rule, If it is concentrated, then we take the concentrated effect, which is Cl negative, right? So again, it is from ions want to become atoms. And chlorine is a diatomic molecule, so we put 2 in here. And the Cl at the left side is still 1, so we put 2. Now, just because we put 2, the charge at the left side is 2 negative, and that's why we put 2 electron at the right to make it balance. So the correct answer here is B. Question 7. Which equation represents the overall reaction in a hydrogen-oxygen fuel cell? Okay, this is very easy. Hydrogen is H2 and oxygen is O2. So the only product for hydrogen-oxygen fuel cell is water. Now balance this equation. So we have O2 in here, but the O is still 1 in here. And that's why I will put 2 in front. Now the hydrogen is affected. So the hydrogen here is 4, and that's why I will put 2 in front of H2. Okay, now let's check it one more time. 2 times 2, 4. So hydrogen here is 4, oxygen here is 2, hydrogen here is 4, and oxygen here is 2 times 1 equals to 1. So the correct answer is A. Next, question 8. Molten zinc oxide is electrolyzed using inert electrodes. Which row identifies the product at each electrode? Okay, so this one is pretty easy because it's just molten. So that means it doesn't have water, right? Zinc oxide, ZnO. So what is the ions? Zn2 positive and O2 negative. So anode is positive while cathode is negative. So who will attract it to positive electrode? Something negative, so oxygen. So who will attract it to negative electrode? Positive ions, which is zinc. So the correct answer here is C. Question 9. Dilute aqueous sodium chloride is electrolyzed by using platinum electrodes. What is the half equation for the reaction at the cathode? Okay, this is almost the same like the previous question. Cathode. What is cathode? Negative electrode. So it is dilute, right? So we have an ACl, and from the water we have H2O. So an ACl is an A positive and Cl negative, while from the water is always H positive and OH negative. So talking about cathode, cathode is negative electrode. So who will attract it to negative electrode? Positive ion, right? So in this case, you can choose between sodium or hydrogen. And what is the rule for choosing positive ion? It is based on the metal reactivity series, and we take the lower position in the metal reactivity series. So if you check it one more time, sodium is at the top while hydrogen is at the bottom, right? So that means we are taking the hydrogen. So hydrogen from ions want to become atom, and hydrogen is diatomic gas. So we put 2. Now the hydrogen at the left side still 1, so that's why we put 2. Now, just because I put 2, the charge at the left side is 2 positive, and that's why I will put 2 electrons at the left side to make it balance. So the charge here is 2 positive plus 2 negative, which is 0. And the charge at the right side is also 0. So the correct answer here is A. Question 10. Which particles are responsible for the transfer of charge in the external circuit during the electrolysis of molten lead to bromide? Okay, this question is pretty easy because the question asking about the charge in the external circuit. So if you still remember, for example, this is the picture of electrolysis. Okay, so this is the electrolyte. So if we are talking about external circuit, it means it is at the cable in here. Okay, so the cable here is moving. So the longer line here is positive and shorter line is negative. So the transfer of charge here is the electron. So the electrons move from positive to negative. Okay, so like this. But the question is only asking about which particles are responsible for the transfer of charge in the external circuit. So we don't care about what is the substance in here. If we are talking about the transfer of the charge, it must be the electron. So the correct answer is D. Question 11. 2 statements about hydrogen are listed. Statement 1. Hydrogen is used as fuel. Do you think this statement is correct? Yes, that's correct. And statement 2. When hydrogen burns in the air to form water, thermal energy is produced. Do you think this statement is correct? Yes, that's it. Because hydrogen, we burn it. Remember, if you want to burn something, oxygen must be exist. And that's why we put O2 in here. And what is the product? Only water. And it is a clean energy. So statement 2 is correct. Now, the question is, which conclusion about these statements is correct? So this is a kind of an analysis statement. Now let's check the option A in here. Both statements are correct. Yes, that is. And statement 2 explains statement 1. Statement 2, when hydrogen burns in the air to form water, thermal energy is produced, and that is why it is used as the fuel. Yeah, that's correct. Since it can produce energy, so we can use that to convert this thermal energy into electrical energy, and we can use it as the fuel. Okay, so this one is correct. But let's check with the other option in here. Both statements are correct, but statement 2 does not explain. Nope, it does explain statement 1. So this one is wrong. Option C. Statement 1 is correct, but statement 2 is not correct. As we know, both statements are correct. Okay, the same thing with option D. So C and D are wrong. Then the correct answer here is A. Question 12. Concentrated aqueous copper 2 chloride is electrolyzed using carbon electrode. What is formed at each electrode? Okay, so let's take a look in here. Copper 2 chloride. So CuCl2. And what is the ions? Cu2 positive and Cl negative. While from the water, again, it always H positive and OH negative. Now, this is concentrated. If you still remember how is the negative ions taken if it is concentrated, we take the concentration effect. So that means we have more CuCl2 than H2O, right? Because it is concentrated. So we have more CuCl2 and we have less water in here. And that's why we will take chlorine. Then what about the positive ion? For positive ions which is attracted to negative electrode is based on the metal reactivity series, right? And we take the lower position. So if you check in the metal reactivity series one more time, hydrogen is above copper. So hydrogen, copper, silver, gold, right? So copper is in here. That's why we are choosing copper ions which is attracted at the negative electrode, right? So for the negative electrode, it is copper, and for the positive electrode is chlorine. So the correct answer here is B. Question 13. Aqueous copper 2 sulfate is electrolyzed using copper electrodes. Which statement is correct? Okay, so remember the clue here is using copper electrodes. So this is not inert electrodes. Remember, inert electrodes, we can use carbon, graphite, or platinum. Inert means unreactive. Okay, so this is not inert electrodes. So it will get interfere in the electrolysis process. So the process is going to be like this. Okay, so this is copper 2 sulfate, CuSO4, right? While the electrode is copper. So what will happen in here? So remember, this is positive and this is negative because this is longer line, right? As we know, the electron is always moving from positive to negative. Since everything is copper in here, so that means it is just transferring of ions from positive to negative. So all the ions of copper will move from anode to cathode, right? So the ionic half equation at the anode or positive electrode is from elements 1 to become ions, right? Cu2 positive. And then I will put the electron in here. While at the cathode or negative electrode, it is from ions become atom, right? So the electron is at the left side. Okay, now let's check the option here. Option A, oxygen gas is produced at the positive electrode? No. Option B, the blue color of the solution gradually fades. So it means the color is changing. So do you think there is the changing of the color? No, because it is just the transferring of ions from positive electrode to negative electrode, right? So that means these anode will become thinner and these cathode will become thicker because you transfer all the ions from positive to negative, while the concentration here is the same because it is just transferring of ions, right? So statement B is also wrong. Next, the concentration of copper ions in the solution stays the same. Yes, that's correct because it is just the transferring of ions from positive electrode to negative electrode, right? Next, the mass of a negative electrode decreases. Negative electrode is the cathode. Do you think it decreased? No, it increased because the ions of copper 2 positive is transferred from positive electrode to negative electrode, right? So anode will decrease in mass while cathode will increase in mass, right? So the correct answer here is C. Next, question 14. Which row describes the reaction during the electrolysis of dilute aqueous sodium chloride? Okay, so sodium chloride, NaCl, right? From the water is H2O. So the ions here is an A positive, Cl negative. From the water is always H positive, OH negative. So anode is the positive electrode while cathode is negative electrode. So the clue here is dilute, okay? So that means dilute, you have more water. So the water here is more while the NaCl here is less. Again, if it is dilute, so that means you have more water. So that's why we are taking the OH negative. So the OH negative is taken at the anode. So this one. What about the cathode? For the cathode, we have an A positive or H positive. Now, if you check in the metal reactivity series one more time, sodium is at the top while hydrogen is at the bottom. So we are choosing hydrogen, right? So it is from ions want to become atoms. And hydrogen is the diatomic gas. So we put 2 and we put 2 in here and we balance it by putting 2 electrons at the left side. So this one. So from here, we know the correct answer is D. Question 15. Hydrogen-oxygen fuel cells are used in electric cars. 3 statements about these fuel cells are listed. Which statements are correct? Okay, let's check each statement in here. Statement 1. The process in the cell is called electrolysis. This one is wrong because this is not electrolysis. It's just the reaction between hydrogen with oxygen, which produce water, right? There is no electrolysis in the cell. Next, water is broken down in the cell to produce hydrogen, oxygen, and electricity. Well, if you see the reaction here, we react hydrogen and oxygen. So it is not broken down, but we react hydrogen and oxygen to produce water. So it does not produce hydrogen and oxygen, but it produces water and electricity. So statement 2 is also wrong. Next, water is the only chemical product formed in the reaction. Yes, it is. There is no other product instead of water only. So this statement is correct. So which statement are correct? 3 only. The answer is D. Now it's your turn to solve some of these multiple choice past paper questions. You may pause the video to think for a while and please write your answer in the comment section below. I will check your answer and reply every comments. Question 16. Question 17. Question 18. Question 19. Question 20. Okay, now let's move to the structure question. Question 1. Molten and aqueous sodium chloride are separately electrolyzed using inert electrodes. Name a suitable inert non-metal electrode and a suitable inert metal electrode. As we know, for inert electrode, we can use graphite or carbon or platinum, right? So the non-metal here is going to be graphite because graphite is not a metal. You can also use carbon. And what is the metal electrode? Platinum, because platinum is a metal. Next, complete table 3.1 to show the name of the product formed at the cathode during the electrolysis of different forms of sodium chloride. Okay, so remember, what is cathode? Cathode is negative electrode. So what kind of ions that will attract it to negative? Positive ions, right? So molten sodium chloride, it is an ACl, right? There is no water in it. So an ACl, the ions is an A positive and Cl negative. Okay, so who will attract it to cathode? Positive ion. So it should be sodium. Next, dilute aqueous solution. So dilute here means a lot of water, right? So from the water itself is H positive and OH negative. So who will attract it to negative? Positive ion. And as we know, sodium is above while hydrogen is below. So we take the lower position. So it must be hydrogen. What about concentrated? Still, for positive ions, we take the lower position in the metal reactivity series. So we still take hydrogen in this case. Okay, that's it. Next, question 2. A student uses electrolysis to electroplate a zinc rod with silver. The student uses the apparatus shown in figure 1.1. Name the item of apparatus label A in figure 1.1. Okay, so what is A? What is that? It is beaker, right? Next, the zinc rod is used as the cathode in figure 1.1. Identify the element that is used as the anode. If you check in the notes in my previous video, remember the thing that you want to cover is put at the cathode, while the metal that you want to use that to cover the metal in electrolysis, we put it at anode, right? So the zinc rod must be put at the cathode, while the silver should be put in anode. So the element that is used as the anode is silver, right? Suggest a suitable electrolyte. Okay, so I want to cover this zinc rod with silver. So, of course, the electrolyte in here must be contain something silver. So in this case, I can use what? Silver nitrate, but it should be in liquid, right? So you have to write the word aqueous silver nitrate. Next, a teacher uses the apparatus in figure 1.2 to make chlorine gas by electrolysis. Chlorine gas is toxic. Describe how the teacher can confirm that chlorine gas comes out of the side arm during electrolysis. So this side arm and the output here is chlorine gas. So what is the task for chlorine gas? So we can insert damp litmus paper and it will bleach or turn white. Next, state one safety precaution that should be taken due to the formation of chlorine gas in this experiment. So as we know, the chlorine gas is a toxic gas. So how we do the experiment? We do the experiment in a fume cupboard, right? So what is a fume cupboard? A fume cupboard is used to keep people safe from chemical smell, smoke, or any gases by pulling them away from the users. Or I can say a fume cupboard protects people by removing harmful gases from the work area, especially in the laboratory. Okay? Question 3. Ionic compounds can be decomposed by the passage of an electric current using inert electrodes. State the name of this process. Okay, so what kind of process is this? This is what we call electrolysis, right? Next, write the ionic half equation for the reaction which takes place at the anode when molten potassium bromide KBr is decomposed by the passage of an electric current. So this is just molten. It is not dilute or concentrated. Molten means there is no water. So you only have the compound itself. So we have KBr, right? So what is the ions? K positive and Br negative. And anode means it is the positive electrode. So who will attract it to positive? Something negative, right? So which is Br negative. And the question asking about the ionic half equation. So that means it is involving electrons. So from ions want to become atom, Br. And bromine, Br, is diatomic molecules. So we put 2 in here, and to balance it, I will also put 2. So now the charge at the left side is 2 negative. So where should I put the electron? Should be at the right side. 2 electron. Okay? Next. Name the product and state the observation at the negative and positive electrode when dilute aqueous potassium bromide KBr is decomposed by the passage of an electric current. So this is dilute, right? And this is the negative electrode. So from KBr, we have K positive and Br negative. While from the water, we always have H positive and OH negative. So this is negative electrode. So who will attract it to negative? Positive ion. So we can choose between potassium or hydrogen. And if you check in the metal reactivity series, potassium is above hydrogen. So we are taking the lower position in the metal reactivity series, which is hydrogen, right? So the product here is hydrogen. Next, what can you observe at the negative electrode? The product here is mean the name of the chemical compound, while observation is something that you can see with your eyes. So you don't write, I see hydrogen gas, but you can just write bubbles of gas. Okay, and if you want to make it clear, you can also write bubbles of colorless gas because hydrogen is colorless. Next, what is the product at the positive electrode? So who will attract it to positive? Negative ions, which is Br negative or maybe OH negative. But this one is dilute. If dilute, so that means we have more water and the Br negatives is less. And that's why we are taking the more, which is OH negative. So what is that? What is the product? 4 OH negative will become O2 plus H2O, right? And how many electron? 4 electron. And make sure you balance this chemical equation. We put 2 in here, okay? So what is the product at the positive electrode? Oxygen and water. Next, what can you observe at the positive electrode? So this is the oxygen gas and this is water. Oxygen is also colorless gas. So you can also say bubbles of colorless gas or bubbles of gas. Question 4. This question is about electrolysis. Complete the definition of electrolysis by filling in the missing words. I think I already told you what is the best definition of electrolysis. It is the breaking down or decomposition of ionic compounds into molten or aqueous solution by using electricity, right? The decomposition of ionic compounds. When molten or in aqueous solution by using electricity or by the passage of an electric current. Okay, next. Electrolysis of aqueous copper 2 sulfate is carried out using the apparatus shown in figure 3.1. The electrodes are made of platinum. So platinum is the inert electrode, right? It is just the same with carbon. Okay, so what you need to know in here is this is positive charge and this is the negative. So the positive in here will make this electrode as the positive electrode, right? So this is anode or the positive electrode. When it is connected to negative power supply, so this electrode will become cathode or negative electrode. So we have copper 2 sulfate. So what is the formula of copper 2 sulfate? It is CuSO4, right? So the ions here is Cu2 positive and SO4 2 negative. While from the water, we have H positive and OH negative. Okay, so who will attract it to anode? Negative ions, right? Which is SO4 2 negative or OH negative. So remember, we never electrolysis sulfate. In this case, we are choosing OH negative. So 4 OH negative will become O2 plus 2H2O plus 4 electron. Then who will attract it to negative electrode? Positive ion. So copper or hydrogen. So if you check in the metal reactivity series, copper is below hydrogen, right? So hydrogen and then copper, silver, gold. So we are taking copper because it is lower in the metal reactivity series. So it is from ions want to become atom. Okay, so how to balance this chemical equation? We put 2 electrons at the left side. Next, the question said, state whether the mass of the cathode increases, decreases, or remains the same when platinum electrodes are used. The mass of cathode, so this is the cathode, right? So you can see in here, the ions keep accumulated in here. So we can say in here, what can you observe? It is the red metals deposit because all the ions will get accumulated and will turn into copper metal. So it will become thicker and thicker over time. So the mass will increase. Next, describe the change in appearance, if any, of the electrolyte when platinum electrodes are used. What is the electrolyte? So do you think you find any changing in here? Okay, so who is taken in here? We are taking OH negative at the anode and we are taking Cu2 positive at the cathode. So who is left in the electrolyte? It is SO4 2 negative and H positive. So what is that? H2SO4, right? Which is sulfuric acid. So the solutions will become acid because sulfuric acid is left in the solution. But the question here say, what is the change in appearance? The original color of copper 2 sulfate solution is blue. At the end of the reaction, sulfuric acid is left in the solution, which is colorless. Remember, most acids are colorless. So the blue solutions turns colorless. So you can write in here, it becomes colorless. Next, describe what is seen at the anode when platinum electrodes are used. What can you see in here? Oxygen gas, right? Oxygen and water. So you can just say bubbles of colorless gas or bubbles of gas. Next, write the ionic half equation for the reaction at the anode. Okay, so actually we already write in here. Okay, so just rewrite it in here. Next, the electrolysis is repeated using copper electrodes. State whether the mass of the cathode increases, decreases, or remains the same when copper electrodes are used. Again, if everything is copper, so it is just the same with the movement of ions from positive to negative, right? Because it is just the moving ions from positive to negative electrode. So the mass at the positive electrode will decrease and the mass or the size of the cathode will increase because everything from here moved to here, right? So the question is asking about the mass of the cathode, so we know it should be increased. Next, describe the change in appearance, if any, of the electrolyte when copper electrodes are used. Again, so if we are using copper, nothing changing, right? Because it is just the moving. All the ions from positive move to negative. So the concentration remains the same. So from here, we can know there is no change. Question 5. Metal spoons can be electroplated with silver. Describe how a metal spoon can be electroplated with silver. Include in your answer how you could determine the mass of the silver electroplated onto the metal spoon. You are provided with solid silver nitrate, a metal spoon, a piece of solid silver, distilled water, and common laboratory apparatus. You must include a diagram in your answer. Okay, so first of all, let's draw the diagram. So we have the power supply in here. Okay, so the power supply here, this is the positive and this is the negative. Remember, the thing that you want to cover or the spoon should be connected to the cathode or negative electrode, and the piece of the metal should be connected to the anode or positive electrode, right? So you can name, don't forget to name it. So this is the cathode in here, or this is the spoon, and this is the anode, or we can say this is the silver metal. And what is the electrolyte in here? AgNO3, and don't forget should be equals, right? And what is the step-by-step in here? So first of all, we measure and record the initial mass of the metal spoon using a balance, right? And next step, dissolve the solid silver nitrate in distilled water to prepare a silver nitrate as the electrolyte. And then, set up the apparatus as shown above. Connect the metal spoon to the negative terminal or cathode and the silver to the positive terminal or anode. Next, switch on the power supply and allow electrolysis to take place until the spoon is coated with silver. Next step, after electrolysis, remove the spoon, wash it with distilled water, and dry it. And finally, we measure the final mass of the spoon. The mass of silver electroplated onto the spoon is calculated by using the mass of the silver deposited equals to final mass of the spoon minus the initial mass of the spoon. Okay? That is how you got the full mark for this question. So that's all about some past paper question in this question and answer about electrochemistry. Thanks for watching. Don't forget to like, comment, and subscribe. See you again.